afternoon. Let's look at some examples and some vocabulary from Chapter 4. So some of the vocabulary you need to know are things like greatest common monomial factor. Now this is something when I look at an example like 6x squared plus 2x plus 4. What is a number I can pull out of all three of those terms? Well, if I look at it, I could take a 2 out of 6, I could take a 2 out of 2, and I could take a 2 out of 4. So I would have 2 times 3x squared plus x plus 2. So I've taken, this is my greatest common factor. And it's a monomial because it's just one part. Now when we're looking at perfect square trinomial factoring, this is something where the number that's in front is a number that you could take the square root of and get something perfect. So if I look at 9, the square root of 9 would give me 3. If I look at 16, the square root of 16 would give me 4. So it's an example of a perfect square trinomial factoring. So I can break that down into 3x minus 4, 3x plus 4, and the key to look at is the fact that this number and that number are exactly the same, and that this number and this number are exactly the same. Now the signs in the center are different, but it's the number that we're really looking at to see if we have something that's exactly the same, where we could take the square root. Now let's look at the first example for today. Here we want to be able to factor 5x squared minus 17x plus 6. Now, we've been dealing with things that had a coefficient of 1. Well, now we have a coefficient of 5. So I actually have to think about the factors of 5 and the factors of 6 and what I would get from my outside and inside terms in order to get a negative 17. So I'm going to write down all the factors I have of 5. I could have 1 and 5. I could have 5 and 1. And today the order is actually going to matter. If I think about 6, let's think about all of the different examples I could have. I could have 1 and 6, I could have 6 and 1, I could have 2 and 3, I could have 3 and 2. Now I need to look at my outside and inside terms to find out which one will give me a negative 17. So if I multiply these numbers together, and I multiply these numbers together, because I'm thinking about my outside and inside terms, which ones will add up to a negative 17? Well, here, the 5 times 1 is going to give me 5. And if I take the 1 times 6, that's going to give me 6. Well, that adds up to 11. So I know that's not going to work out. So I'm not even going to bother trying the second pair. So let's think about another example. If I do 1 and 5, let's try it with a 2 and 3. Write it down here so you can see what I'm doing. So I'm looking at my inside terms and I'm looking at my outside terms. Here I would get 10 and here I get 3. Well, that's 13. I'm looking for a negative 17, so that's not going to work. Let's try the next pair, 3 and 2. So I'm going to have 1 and 5 and 3 and 2. So if I look at these, I'm going to get 15. And if I look at these, I'm going to get 2. Well, if I add those up, that's giving me a 17. And that's really close, but I want a negative 17. So what I'm actually going to do is change the sign on both of these to negative. So that would give me a negative 15 and a negative 2, which would give me a negative 17. So now I know the information about what I need to put in the front of my factors. I'm taking this set, and I'm putting that part in front, 1 and 5. In the order that I have it listed here. Because there's an x attached, I'm going to put an x here. Now here I need the negative 3 and the negative 2 in the second part of each factor. Now I'm going to FOIL it out just to make sure I really have got the right thing. So if I look at this, I'm going to get my 5x squared. When I look at my outside terms, I'm getting a negative 2x. If I look at my inside terms, I get a negative 15x. And if I look at my last terms, I get plus 6. Now if I combine my like terms that are in the center, I'm going to get a negative 17x plus 6. And I'm going to drag the 5x x squared along. So I know that this answer is factored correctly because when I FOILed out the factors, I was able to get back what I started with. Let's look at another example of this variety. Here I have 3x squared minus 10x plus 8. Again, let's think about all the factors of 3. Well, I can either do 3 and 1 or 1 and 3. If I think about 8, I could do things like 1 and 8, 8 and 1, 2 and 4, 4 and 2. Remember, the order matters. So let's look at our outside and inside terms. Well, if I multiply these together, I'm going to get 1. And if I multiply these outside numbers, I'm going to get 24. Well, that's way too big, so that's not the right pair. Let's skip the other 8s because it's probably going to be just as big. Let's do it with the 2 and 4. So I'm going to rewrite 3, 1, and 2, 4. So I'm multiplying those numbers together, so that's going to give me 2. And the outside is going to give me 12. Well, if I add those up, that's going to give me 14, and that's still bigger than what we have. So we need to try another combination. Let's flip the order that they're in. If I have a 3 and a 1 and a 4 and a 2, if I multiply those together, that's going to give me 4. If I multiply that together, it's going to give me 6. Yay, that's adding up to give me 10. But wait a minute, I need a negative 10, so I'm going to change the signs of both of those to negative, because a negative 4 times a negative 2 would give me the positive 8, so that's an okay factor. So let's write down what we have so far. I know that these numbers have to go in the front of my factors, so I have 3x and 1x. I know that these factors have to go in the back, negative 4, negative 2. So now let's FOIL it just to make sure that we did it right. Look at this part, I'm going to get 3x squared. If I look at this part, I'm going to get minus 6x. If I look at this part, I get minus 4x. And when I multiply this part, I'm going to get plus 8. So if I combine my like terms, I'm going to get 3x squared minus 10x plus 8. So now I know that I actually factored it correctly. So that is my answer. So that's the end of example number 1. Have a great day. Bye.